Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on Prosper software. And today's topic is about hydraulic jet pump. We will design the jet pump, we will install it to our well, and we will perform nodal analysis. Okay, so as usual, we start with this step. Okay, you can follow me. Fluid description, oil and water, method black oil, spirator, single stage spirator, no emulsion, disable PVT warning. Water viscosity, we will use default correlation. And for viscosity model, Newtonian fluid. For well, flow type tubing flow, well type producer. And this one is important. Artificial lift, open the drop down menu, find jet pump. Okay, jet pump. And for the type, we will select annular injection, tubing production. Okay, so injection will be on the annulus, whereas the production will be through the tubing. Calculation type, offshore, rough approximation, full system, brine modeling default, well completion cased hole, no send control, single branch, and no gas conning. You can also type in the user information, the user comments as per your condition. Okay, so we can click done and we will wait. Okay, so now the PVT section is available. We can input our PVT data on the second tab. Okay, let's go in. Okay, so you can follow me for the input data solution GOR 800 standard cubic feet per stock tank barrel, oil gravity 37. Okay, 37. The gas gravity 0.76, water salinity 23,000 ppm, no H2S, no CO2, no nitrogen. For the bubble point pressure, solution GOR and oil formation volume factor, we will use Glasso correlation. For oil viscosity correlation, we will use Bill et al. Correlation. Okay, if you have laboratory data, you can do matching, but we will skip this feature for the time being. Okay, you can input your lab data in this section and perform matching. Okay, I will skip it and press cancel. All right, so far so good. And this one, other data section, we need to input information about our power fluid. Okay, first viscosity, Newtonian fluid, emulsion, no emulsion. Okay, for the power fluid. Okay, power flow type, power fluid type, water with water salinity of 75,000 ppm. Okay, all right, click done. Okay, so we don't do PVT matching in this video. Now we go to IPR data section. I will select PI entry to make it more simpler. All right, to make it simple. Reservoir data, reservoir pressure 3500 psig, reservoir temperature 210, water cut 80%. Later on, we will do sensitivity analysis on the water cut, but we still need to input the water cut information here. Total GOR 800 SAF per STB automatically imputed by the Prosper because previously we input this information, this parameter on the PVT section. No compaction, no relative permeability modeling. Okay, so for this IPR model, we need to input PI only, and the productivity index is 6.5 stock tank barrel per day per PSI. Okay, we can click calculate. So you can see the AOF, the maximum flow rate is almost 16,000 stock tank barrel per day. Okay, you can click view results. All right, this one, these three columns. Okay, you can copy and paste on your spreadsheet. Click done, and you can click this one, plot results, to plot the pressure, temperature, and others. I want to show the pressure and temperature, for example. Click done. All right, so this is the IPR trend, whereas this one, the orange line, shows us the temperature. Most of the time, I don't need the temperature, and I will just only concentrating on this IPR plot. Okay, finish, done, done. All right, so we have our IPR. As usual, from IPR data section, we will go to equipment data section. We will input information about the deviation survey, downhole equipment, geothermal gradient, and for average capacities, we will use default numbers. All right, click edit, deviation survey. You can follow my data, measured depth, MD, and true vertical depth, or TVD, 00, 600, 600, still vertical section, 1005, 1000, starts to deviate. So we will create a deviated well here, 4075, 4000, 7700, 7500, and lastly 9275 at 9000. You can click plot to show the configuration, measured depth against cumulative displacement. Finish, click done. Now we need to input the downhole equipment, starting from the Christmas tree. This is an offshore well. The measured depth 600 feet. Then we have tubing. Open the drop-down menu. The bottom of the first tubing is 1000, 4.052, default roughness, outside diameter 4.5, casing inside diameter 6.4. So from here, we can get the result for the annulus dimension, all right? The size, the dimension, or the volume of the annulus can be calculated automatically by the Prosper, all right? So yeah, you can see we provide the information on the casing inside diameter and the tubing outside diameter. And of course, we can calculate the annulus volume. After the tubing, we will have subsurface safety valve, triple S and V, with smaller inside diameter of 3.72. Again, we will have next tubing section down to 6,000 feet. I can copy everything here, Control C and Control V. Okay. Lastly, I will have my casing to the bottom of my well with the same casing inside diameter, 6.4. All right. And the same roughness. And for the rate multiplier, all one. Okay. There is no redirection of the flow. The flow will be on or will be inside the tubing, inside the safety valve, inside the tubing 100%. Okay. After this section, we will have geothermal gradient, overall heat transfer coefficient 8.6. All right, the depth reference at the rotary calibushing, and we will input measure depth here, At zero depth, the temperature is 60 degrees Fahrenheit. At Christmas tree level, 600 feet, temperature is a bit cooler, 40 degrees Fahrenheit. And at reservoir depth, the temperature is of course 210. So far so good, click done. All right, now the equipment data section is completed. You can check again at summary. All right, equipment summary in a table. And you can also draw downhole by clicking this button. All right, so this is our well configuration, the Christmas tree, the tubing, the safety valve, tubing, and casing. Okay, so far so good. You can check also the MD, the measured depth, and the TVD, the true vertical depth. Click done, done, done. And we will wait for the well schematic. All right, so this is our well schematic. So from here, we will go to the design section and we will design hydraulic jet pump. Okay, let's go ahead. Click design, find jet pump. Okay, so you can see the window or the wizard for jet pump design is quite simple. All right,